Morgan, where are you at?
Number 26 on page 83 in the review.
Okay, Morgan, this is the exact same question we asked yesterday, or we answered yesterday. Okay, so Campbell asked this question. Campbell, what question did you ask yesterday?
28.
28?
Yeah.
It's the exact same question. Okay, so the East Bunny runs along a straight and narrow path with a constant speed of 25 meters per second. So he's at constant speed, which means that there is only distance, time, and velocity. I don't have anything else because he's going as, so like if I set the cruise control in the car and I'm traveling at 100 kilometers an hour for 1 hour, I get the distance by multiplying them. You understand what I'm saying? A constant speed means that you don't have a V1, you don't have a V2, you don't have an A. It's just V.
Just that speed.
Yes.
Okay.
Follow that? Okay. He passes the sleeping tortoise, which immediately starts to chase the bunny with a constant acceleration. So the tortoise is at V1, is at 0 meters per second. He's accelerating at 3 times 10 to the negative 3 meters per second squared. Oh, how long does it take the tortoise to catch the bunny? Alright, so, again, this is one of those questions I said you didn't need to answer because it's a sin 80. That means it's a contest question, but whatever, we'll do it because you'll see this again. Alright, so how do I find the distance when I know the velocity and I know the time?
It's a little tricky because both units are missing. I know you just,
Velocity times time.
but there's no time.
We don't know it yet, but I gotta use it to solve, okay?
Okay.
Alright, so I put velocity times time here. That's how I get my distance.
Yeah.
We know the distances are the same because he catches the other guy.
Yeah.
Okay, so this one is V1 delta T plus 1/2 A delta T squared. Okay, that's the distance for this guy.
Okay.
Alright, again, I don't know the time.
Yeah.
I don't know the distance, but that's how I find the distance. Because I know the distances are equal.
Yes.
So I put them together. So now what I have is I have 25T equals, this is 0.
Yeah.
So 1/2 of that value times T squared.
Yeah, that's what I got.
Okay.
And then,
Alright, now, I'm just going to show you the simple way of doing it for this class. Okay?
okay.
You're going to divide by T to start with. So when I divide this by T, that gets rid of that guy. And divide this side by T, that gets rid of one of them.
Yep.
Now I need to divide by that to get T by itself. So take 25 and divide it by that.
I got 166. No, that's a long number.
60,666.667.
Would you agree?
Yeah, I got that same answer.
Okay. That's in seconds. The question asks you to do them in hours. How do I change seconds to hours?
Seconds into hours. Divide by 60 twice.
That's right. Good for you. That's right.
Then
Which is
convert it.
3,600. So take that number and divide it by 3,600.
4.62.
There's your answer.
Okay, the part with the T's there is the part that
Up here?
mixes me up.
Which part? Here or here?
Well, the ending part, the other ending part I understand. The equation, that equation's from the equation list, right? Or was it juggled?
This is distance is equal to velocity times time. If you have a constant speed and you have a time, you multiply them to get your distance,
Yeah.
okay? So if I go 100 kilometers an hour for 3 hours, how far did I go?
Mm,
I'm traveling 100 kilometers for each hour, and I went 3 hours. How far did I go?
you divide that number by 3.
Think about what, no, Morgan. If you go 100 kilometers in 1 hour, how far have you gone?
100 kilometers.
And then you do it for another hour, how far have you gone?
100 kilometers.
Again, so how much is that?
200 kilometers.
And then if I go for a third hour, how far have I gone?
300 kilometers.
So am I dividing or am I multiplying?
Multiply.
I'm taking my velocity times my time.
Oh, I see.
Okay?
Yep.
Make sense of that now?
Yep.
So to get the distance for this guy, I take the 25 times t. I know I don't know what t is,
Yeah.
okay? But I can solve for it. I'm trying to eliminate variables so that I can solve for it. Okay? Over here, this is the third equation on your list. D equals v1 delta t plus 1/2 at squared. Okay? Again, I don't know what t is. But I know what v is and I know what a is. It's given to me. Following me?
Yep.
You sure?
So that equation you find,
That's also equal to displacement. That's the third equation on your list.
yeah.
You have a list of,
Both equations find the distance.
yes, that's correct. And we know that the distances are the same,
Yes.
right?
Right?
So far so good?
Yeah.
Okay? So now, all I've done is try to eliminate all the variables. And what did I get left with? A t squared and a t.
Yeah.
So at that point, now I solve for t.
So you cancel t.
Yeah.
And why do you divide by 1.5 times 10 to the negative 3, or maybe getting it backwards?
How do I solve for x?
Divide by 2.
How do I solve for t?
Divide by 15, no, 1.5 times 10 to the negative 3. Oh, I see, that t was still there.
Mm-hmm.
Okay.
If I take t squared, I divide it by 1t. I'm still left with a t.
Okay. That's where it got mixed up.
Okay? You okay?
Yeah.
Better?
Better, yeah.
Okay? So this is the second time we've done this question. Number 28 is the same question. So maybe go do 28 right now. Okay?
Okay.
And because it's done the same way.
Okay.
Alright? Other questions today? Sam?
Number 5. I remember doing that last year, but I think I did it.
So you have a jet that travels at 700 kilometers per hour.
Yeah.
Okay? The amount of fuel you have in a tank is 6,840 liters. Now a jet uses up 38 liters every minute. So the consumption
I have things backwards.
is 38 liters every minute. So you need to find out how long it's going to take to use up 6,840 liters.
Okay, so I need to change my 38 liters per minute to hours.
I wouldn't do it until after I'm done with dividing, but yeah, that's right. And then once you have that, then you know how long you traveled for, that's the speed, that'll tell you how far
my fuel divided by my velocity and times by my consumption. Oh, I have a number.
Okay.
Change whatever the difference is.
Rory, Tom,
I'll just ask you.
what do you need?
So you just divide 6,840 by 38,
Yeah.
and then you would multiply that to get your hours.
Mhm. Well, you would get your number of minutes. So this is gonna tell you, if I divide these two, that tells you how many minutes it's gonna take
Yeah.
before you run out of fuel.
And
You
then
change that to hours, and then you can find out how far you can fly, because you're flying 700 kilometers per hour.
You could just change it to hours right off the start, though, couldn't you?
You could, but I find it gets confusing for some people, because the minutes is on the bottom. But yes. Okay?
It's just on the thing here, like for 12, I mean, this is like a British jump into the master of 3,000 years. We found that in unknown comparisons, and then we want you to correspond your average acceleration right above this is right up to 0.35 meters per second squared. Okay, and then it says y is the value of the average acceleration less than y is.
I drop these at the same time. Are they gonna hit the ground at the same time? How come?
Because that one is more dense. They both have the same area resistance, but one is more mass.
I was heavy, but
it's heavier.
That's heavy.
Okay, you're right, you use the right terminology, more mass. You're right. Okay, so then the question's asking you what actually affects? What is it that affects?
Terminal velocity.
Okay, no, do you know what terminal velocity is?
Yeah, it's like the maximum amount something can fall down with air resistance, right? It's when your air resistance meets the effects of gravity.
Okay, so you're on the right track. That's very good. Okay, so now, if I fold this up, all right, which is gonna hit the ground first, this? Or if I fold that up or crumple it up?
Like that. So,
How come?
because it's less air
Because it has less air resistance? So there's one of your factors that affect it, right?
does this balloonist have balloons attached to it?
Sorry?
So, this balloonist might have like something attached to it that was, so that was,
I don't think so.
You had an unopened parachute.
Yeah. So then what happens when parachute opens?
even more.
Right, so there's your air, right?
So this,
You got more air resistance.
On that same question he was talking about, I didn't know how to do F. That's kind of like terminal velocity. What was the terminal velocity captured just before the splashdown? I see it's -70, 7, but I don't know how to look at that. This is when the splash, I'm not sure if this is text,
Yeah.
but what it is.
No.
Okay, so we have it out now.
So you slow down. So at that point, your air resistance is equal to the acceleration of gravity. They work against each other.
Okay.
So then you could,
That's when it's heating the water.
right? So could you find out what the velocity 2 is at this point? This is your velocity 1 down here, that would be your velocity 2 right there.
Yeah.
So maybe they maybe said -7, I don't know.
This might be where this might be too.
You go look in that answer key back there and see what, I don't think there's only, I don't know, if you can find your V2 in that interval. But it's off the graph, right? Anybody else have questions today? Jeffrey? I can't hear you, Jeffrey.
Can you just come here?
So anybody else have questions that needs to be done on the board? On, number? 25? So the question off the worksheet? Okay? Prove that the police car overtakes the sports car, so you gotta find the displacement at 60 seconds for both of them. Yeah? Okay, so. Let's look at the displacement of the police car. Okay? So the police car starts at 40 meters per second, doing 20 meters per second right here, and that's 60 seconds down here, right? Okay, so 1,200 meters there. Okay? 20 by 60. Yes? So 20 by 60 divided by 2, 600 meters right here. So how far has he gone? meters. What's the problem?
How do you get?
This is a rectangle, do you agree? And this distance here is 20. Sorry, velocity is 20 meters per second. You're going 20 meters per second for 60 seconds. How far did you go? You get that? This is a triangle. Base times height divided by 2. Your base is 60. Your height is 20, and you gotta divide that by 2. 600 meters. Add the two together, you get 1,800 meters. Now in theory, this is a trapezoid too. So you could actually use base 1 plus base 2 times 2, or divided by 2 times your height. We get you the same equation. But that's how I found it. That's the displacement under the graph. Agreed? Yeah? So now, the police car, or sports car, sorry. No, police car now. This was the sports car. The police car, he starts at 0. So I got a triangle here. And he's going, this is 40 for 30 seconds. So that's 1,200 meters divided by 2. So this part is 600 meters. Right? So from 0 to 30, the police car is going 600 meters. Yes or no? You're okay? So now I've got from 30 to 60, right? Is he going at a constant speed from 30 to 60? Yeah? So therefore I've got a rectangle. So for 30 seconds he's going 40. 1,200 meters. What's 1,200 and 600 make? 1,800 meters. You understand all of that?
Yep.
Okay? So, when I have a VT graph, if I find the slope of the lines, that gives me acceleration. Okay? If I find the displacement, or the distance under the graph using the shapes, that gives me my distance, or my displacement. Now you can do that on your test? You're on your assignment? Okay? Yeah, no problem. Anybody else? Mary?
Is it the same for 2043?
Yeah.
I still kind of look at it as the distance.
Okay, let's focus on the sports car here. Alright? Let's look at the graph. So the graph looks like this. The sports car is the easiest one to look at. So it starts right here, and it goes down like this, right? Yeah? Okay, actually, let me do this a different way. Let's say that I do this. This is 40 meters per second. That's how fast I'm going. Okay? And I'm going to do that for 100 seconds. So I'm going at a constant speed of 40 meters per second. No, let me change that. You're going 100 kilometers an hour for 3 hours. How far did you go?
300.
You sure?
Yeah.
Each hour you go 100 kilometers? So 300 kilometers over 3 hours. Do you agree with me?
Yeah.
That's the question I ask all the time. So you got that by taking your velocity and multiplying it by your time, correct? So your displacement is equal to velocity times time, yes? Okay, so you follow me on that. What shape do I have here? Square, rectangle, probably more like it, right? 100 by 3? So I've got 100 here and 3 here. So if I find the area of this, it gives me my displacement. Do you agree with me? Okay. That all makes sense to you now?
Yeah, it's just
Okay,
like.
hold on, I'm not done. I just need that part to make sense before I do the next part, okay? Does that part make sense? Okay, good. So now, I got a sports car that is going 40 meters per second, and he's slowing down, okay? So, I want to find out now, how far did he travel in 60 seconds? Now, he's not going at a constant speed. His speed is slowing down, so I got to find out how far he went. So to do that, I break this guy up into 2 shapes. Okay? So what shape do I have down here? A rectangle. Now I know this is 20 meters per second right here. So that means this is 20 by 60. So how do I find out how far he went in that square?
Times 20 by 6.
So I get 1,200 meters. Okay? You okay so far? But I also have this little slowing down part that I have to also focus on, okay? So this guy is 20 right here, and this is 60 right here. Well, what kind of shape do I have there? So how do I find the area of a triangle?
20 times 60 divided by
Right, which gives me 600 meters.
So total distance.
So then the total distance that he traveled from there to there is 1,200 plus 600, which is 1,800. You follow me so far?
Yeah.
Okay, so that distance is 1,800 meters, and that's just based on that. Now, here's another question. I'm going to pose a different question, then I'm going to come back and help you answer what you're actually asking here. My other question is, how fast is he slowing down? What's his deceleration?
40 divided by 60.
Okay, not quite. This coordinate here is what? 0 and 40. You agree? This coordinate right here is 60 and 20. Right? So to get my acceleration right here, I take my y2 minus my y1 over my x2 minus my x1. So that's negative 20 over 60. Yes? So you get that. Does that make sense so far? Okay. So again, this was the last page of your assignment. This was one of the questions that was asked. How fast was the car slowing down? Okay, so far you okay? All right, so now, let's go to the question that you're asking about.
The distance between the two at 30.
Here? Okay, so I gotta find out at 30 seconds how fast each one. Okay, so if you're looking at your sports car, so this is 0-40, right? This is, it said for 30 seconds, agreed? what's the height at 30 seconds? 30? Okay, so that's 30 and 30, right? So now let's find the area underneath the graph. Okay, so this is 30 here. Yes? This is 30 here. Right? So the first block is what? Which is 900 meters. And then what do I do up here? What, 10, which is 50. And then I add those two together. Okay, so then I have 1,050, right? So that's how fast that guy went. So far, so good? Okay, now, a police car does that. Okay, same coordinate here, right? Your starting coordinate is down here. So how far did the police car go in 30 seconds?
40 times 85, so 1,600.
No.
But here it says it,
But you're only going to 30 seconds.
yeah,
So you're only going to, what does he get up to here in 30 seconds?
Yeah.
Sorry, my bad. You're absolutely right there. Okay. You change that. So that's, I thought that ended right there. So let me just- Alright, green, 100. Blue, so that is 30 and 40 there. This guy was 30 and 30. So there, okay, so what did you say it was?
30 times 45,
Yeah,
600.
very good. There you have it. So how far apart are they? 600 which is what? 10 subtract 6. You follow that so far? Okay, I got a question that's not on your sheet now. What's the acceleration of the police car in the first? Hmm?
30 seconds,
What's the acceleration of the police car in the first 30 seconds?
I think that is good acceleration around.
Okay. Does that all make sense to you?
Yeah.
Okay, good. Anybody else? Okay. Jeffrey, I'll be with you. I'm just gonna shut the camera off.